All right, on tonight's edition of Homework Help, I'm working on solving systems of inequalities. This assignment is due tomorrow. So I'm only going to do one from the front. I'm going to do number 1 on the front and number 4 on the back because we've been doing a lot of them, and I feel like you should be getting pretty good at this, but I thought this might throw you off. I think once you know what to do with this, it'll make number 2 a little bit easier. So let's take a look at this and see what we need to do. All right. Remember, when you look at number 2 and 3, you're going to have to convert these into slope-intercept form. But that's something that we should be getting a lot of practice at. Remember, be careful. Make sure that you bring the sign in front of the y down, which doesn't seem to matter here. Okay. So when I have x is greater than or equal to 3, I think this is an x. When I see an x equals or y equals, I think hoi vux. If it ends in x, I'm thinking v-u-x. That means vertical, undefined, or up and down, x equals. So I know that my line is going to go up and down where x is -3. So the reason I still wrote x equals -3 is because that's where I'm going to draw the line. So I have a up and down line at x equals -3. Okay, it's solid because it's or equal to. Now, it says greater than. The reason this one's tricky is because you're like, well, I can't shade above or below. But if you look, greater than, numbers that are bigger go to the right. Numbers that are less go to the left. So since I'm looking for greater than, I'm going to shade everything on the right because the numbers to the right are getting bigger because they're getting more positive. Okay? So that's my first one. And now, when I look at the second one, I have a slope of 5/3. I've got a y-intercept of 2. I have a dashed line, and I'm shading below. My line is also going to be positive because since it's positive slope, it's going to be going uphill. Okay, so I start at +2. I'm going to go up 5 over 3. Can't go any further that way, so I'm going to go back the other direction. My line is solid. Oh, nope, my line is not solid, it's dashed. So again, I'm going to kind of just do some dashed lines there. Okay, I want to make sure that I know it's dashed, but I don't want to do so many dashes that I think it's solid. I mean, like I used to do and then I'd be like, you know what, this line looks solid. Okay, now since it's less than, I'm going to shade below. So I'm going to make my hash marks go in the other direction. So you see it looks like I've got X's there. That's where my double shaded area is. So again, it is difficult to see that. I mean, for me, it's a little easier on the overhead, but when you're actually looking at it in real life, it all looks crazy. So I'm going to trace over with a highlighter my double shaded area so that I can see where my solution set lives. Okay? All right, so that's the first one. That one was pretty easy. Now we're going to look back here. And this is actually not very hard either. For the one back here, I'm going to write for each point, I'm going to try to see which of these points are solutions. So whatever coordinates are solutions, I'm going to write them underneath. Okay? So let's try them. I'm going to go, and I'm only going to do this one. Y'all can do the rest of them. Okay? You can either substitute those coordinates in, or you can plot them on the graph. So since I have a graph, I'm going to use that. Over 0, down 5. That is not a solution to the first one. Over 1, up 5. That one is. -3, -4. Definitely not. Over 3, up 5. Now, this one looks like it is because that line is solid. Okay? 6, 4 over 6 up 4 satisfies one inequality, but it doesn't satisfy the solution. Okay, -6, -1 satisfies one inequality, but not the other. Okay, so I checked all 6 points, and those 2 were solutions. Okay, and that's all you have to do for this is just check and see which ones are solutions and which ones are not.